So this is the situation that we're going to work on today. If you want to write this down, you can. You'll see the same scenario, these 4 sentences on the next slide and the one after that as well. We are going to go over an example of how to create a system from a real-world scenario, and this would be a good one to have to reference back to in your notebooks. So here's what we know. Gina visited the aquarium with some of her cousins, aunts, and uncles. The group bought 20 admission tickets for $340. Adult tickets cost $20, and children's tickets cost $15. How many adult and children's tickets did the group buy? Now, I already mentioned to you that this was going to be a system of equations. However, if you did not know that in advance, what is it about the problem that might hint to you this might be a system and not just a single equation? What do you think?
Because the children and adult tickets have different prices.
How do you know that? Well, you know that you know that they have different prices. The adults cost $20 and the kids cost $15. But what is it about the children and adult tickets here? Not just the price of each individual ticket.
Let it ask how many adult and children's tickets.
Yeah, the question is specifically asking you how many adult and children's tickets did the group buy? How many unknowns are there? There's 2 unknowns, right? It may happen to be that they end up buying the same amount of adult and children's tickets. We're not sure just yet. But we're looking for 2 unknowns. So not always, but that might be the hint for you to set this up, that we have a system here. So now we're going to write 2 equations that represent this real-world scenario. What information do we know? Let's highlight here all the information that is important for us to utilize. What information should we highlight?
Adult tickets.
20 admission tickets for $340.
They bought 20 tickets. The total was $340. What else? Let me do that in a color. What else? Let's go to someone else. What else do we know? Go ahead.
The cost of each ticket.
The cost, be specific. The cost of what?
For the adult ticket and
Good. The adult tickets cost $20. Good. And what else?
the children's tickets cost $15.
Children's tickets cost $15. Good. So can we create equations that represent this?
Ooh.
Well, based on the information that we're given, we want 2 that are related but not identical. Because that's really what a system is. 2 equations that are related. So let's start with 1. Based on this information, could you put together an equation that represents any part of Gina's visit to the aquarium?
Y equals 20x plus 15x.
Think about what we're trying to find. We have 2 unknowns in this problem, right? What are the 2 unknowns?
Adult tickets.
The number of adult tickets.
Wait, excuse me. Why is there?
I know where you're going. We're going to talk very briefly about the use of these variables. What's the issue in the equation here?
They have the same variable.
We have the same variable representing the children's tickets and the adult tickets. Should we have that?
No.
No. So we need to come up with something else. If these are our unknowns, what variables could we use?
HC.
You can use an A for adult,
And
you can use a C for children. Why do you think I would identify that in the beginning?
So you won't mess up.
So I don't mess up. What do you mean by that? You're 100% right. How could I mess up?
You get confused.
I can get confused. Think about this. Think about the systems you've solved already. Some of them are a little time consuming. Imagine if I used X and Y and never wrote down anywhere what X represented or what Y represented. And at the end, I have a value for X. And I don't remember, was X the adult ticket or was X the child's ticket? That's a problem. Because that would change the entire outcome of my problem. So I can identify early a variable. You could use X and Y, but it's a good strategy to identify which variable represents what and to have that written down, just so you know. Another way for you to keep track. So now, using these unknown variables and the information here, we know we have to represent our adult tickets and our children's tickets in some way. Does anyone have any ideas for an equation based on the information we've been provided? Or what do you think?
20A plus 15C equals 340.
20A plus 15C. Could someone explain that equation in words to me?
$20. Wait.
20
Like $20.
What does 20A represent?
$20 per adult.
Ticket.
Is that the 20A?
Yeah, $20 per adult.
Okay, so let's focus in on this right now. In 20A, this is my term. What does the 20 represent?
The cost of each ticket.
The cost for one ticket. And what does the A represent?
Well, how many tickets have
The number of adults. So what would 20A represent? Is that the full term? Because you just told me that the 20 represented the cost for each adult. So 20A can't possibly be the cost for each adult.
What?
If 20 is the cost for one adult's ticket, and A is the number of adults that are going to the aquarium, then what is 20A together?
the total cost?
The total of what?
All the adults.
For all the adult tickets. This would be the total for adult tickets. And the reason I wanted to point that out is on the previous exam, a lot of you got that question wrong about what does the coefficient represent. And you said that the coefficient represented the unknown. But it didn't. The coefficient was something different. Together, they're different. For example, if I have $20 per adult ticket and there's 3 adults, my total price is $60. So it would be $20 for one ticket, and then 3 people went, so we spent $60. So the idea here is that the 20A represents the total cost for adult tickets. What does the 15C represent? What does the 15C represent? The total cost for children's tickets. So the total cost for the adult tickets plus the total cost for the children's tickets equals how much money? $340. Was that information given to us in the beginning that the total amount they spent was $340? Yes. So this equation is good to go. So now let's come back up here. The information that we've used, I'm going to just briefly cross out because we've used it. What other equation can we create here based on the information given? We need one more equation so that we have a system. Because right now we only have one equation, but we need a system. What other equation works? What other information is given to us that we can represent in an equation? What other information? There's still more information given here that we can put into an equation. Because let's think about this. How many combinations of tickets do we think could add up to $340? Say it again. There's still more. Yeah, you're right. There's still other information we didn't pull into.
They bought 20 admission tickets.
They only bought 20 tickets. How can I represent that in an equation? I don't know. What kind of tickets did they buy?
Like
Logistics.
Come on, Lord, just throw ideas out there.
Yeah,
Well,
right
think
now?
about before you go
What is that?
mathy on me. What kind of tickets did they buy?
Children's and
Admission.
Okay, so they bought admission tickets. They only bought two types. They bought adult tickets and they bought children's tickets, and they got 20. Can I represent that in an equation?
You can divide everything by 20, well, on the left side.
Divide by 20. Yeah.
I think I get it. But I don't
This
know.
equation represents the cost, right? The total cost.
Yeah.
There's still more information here, not related to cost, that relates to this problem.
The number of tickets.
The number of tickets. So can we create an equation that represents the number of tickets, not the cost of them, just the number of them?
I mean,
So they bought adult tickets and they bought children's tickets, and there were 20 tickets total. How can we represent that algebraically?
well, 20 tickets, and then 20 tickets costed $340.
Which we already have represented at the top.
I can't see.
We already have an equation representing the cost. We don't have an equation representing the number of tickets.
I don't understand that. So,
A plus C equals 20.
What does that equation mean?
children's tickets.
The number of adult tickets plus the number of children's tickets equal 20. Is that true? Did we only buy adult and children's tickets? Did we only buy 20 tickets? So then that equation must be true. So the top equation there represents the cost, and the other equation represents the number of tickets. Now, if you look at them individually, how many combinations of tickets could you come up with that gave us 20? A lot, right? Like if there were 20 adult tickets and 0 kids tickets, 19 adult, 1 child, 18 adult, 2 children, and on and on and on. How many combinations of 20 tickets could you find that would have given you a total dollar amount of 340? How many combinations of adult and children's tickets do we think there would be 20 tickets purchased and we spent 340?
Well, let's see.
If the system is together, how many do we think we're going to find? How many answers? Just one. We're going to find one answer here. Now, we already talked about what that represents. How can I use these equations to find the total number? I have equations now. Now what do I do to find out my solution? I could substitute or I could eliminate. If you really wanted to graph, you could. It might be a little time consuming, especially because we do have algebraic methods of solving. In terms of solving this equation, which method do you choose to use? This is purely preference because you're going to solve it however you want to solve it. But based on how the equations are right now, does anyone want to offer their suggestion for how to solve? Elimination. Why elimination here? Why are you choosing elimination?
It just makes more sense.
Yeah.
We just did it.
Why?
It's just easy.
What about the equations makes elimination, in your opinion, a little bit easier?
Because you have like the A plus C is 20, and then you have like the 20A plus 15C. Like it's just easier to like, I don't know. Yeah, be able to like multiply or divide the equations by whatever you want to make it.
Okay. Yeah, the layout of the equation might make sense, right? You have the A plus the C equals 20, and then you have 20A plus 15C equals 340. Anyone choosing to substitute just because you prefer substitution? Okay, which equation are you going to utilize to get a variable by itself? The one on the left or the one on the right? Okay, how are you going to get a variable alone? Oh, so you're going to isolate a variable here and then replace it over here. Okay, great. All right, take like 3 minutes, and regardless, whatever method you are going to use to solve, I want you all to try and solve it. This system.
I'm getting an answer.
We're going to go through both methods on the board so you can see how both of them work to find a solution.
I got an answer. That.
Are you done?
No.
Because now you know that, so what else can you find?
A.
Okay, let's do this.
Well, I already.
If you have this laid out that way, what method are you trying to do? Okay, so which equation are you going to multiply to eliminate? Because remember, what eliminates in an equation like this?
I'm sorry.
What do you mean matching? 20 and 20, if I know them?
No, you know magic. Like 20, take 20.
What do you mean by matching?
You know what I mean?
I do, but I'm trying to get you to use the word.
To eliminate
What number eliminates a 20?
negative 20.
A negative 20. What are the opposites? Exactly. Okay, so think about, do you want to eliminate the A or the C? Because that's going to determine what you multiply this entire equation by. Try one of them. Okay, eliminate the children. So what are you going to multiply that entire equation by? A negative 2. You're going to multiply every single thing there by negative 15. Let's start here with substitution. Ew. If I'm going to substitute, what variable can I isolate? For those of you who substituted, what variable did you get alone? A. Okay. How can I get A by itself here?
Minus C.
I can subtract C. Perfect. So this equation can be rewritten. How does this help me?
Substitute for the equation.
So now in the other equation, which I'll write here, what will I replace or substitute? Anywhere I see an A, what can I replace it with? 20 minus C. Good. So down here where I see an A, I'm going to take it out. 20 minus C. Can I solve that equation now? I can. Where would I begin here? I can distribute. Good. 20 times 20 minus 20C plus 15C equals 340. How do I continue to solve? Combine my like terms. What are my like terms here? 20C and what kind of 20 is that? A negative 20C and a positive 15C give me what? And now how do I solve for C? How am I solving for C? Good, I'm subtracting 400. So negative 5C equals negative 60. Last thing. C equals 12. What does that mean?
You got 12 children.
They bought 12 children's tickets. So going back to the beginning, the idea of finding the other variable is a little bit easier here. If they bought 12 children's tickets, how many adult tickets did they buy? 8.
I did the whole equation just to figure that out.
Now, if we wanted to eliminate, and we'll go through this one a little bit faster so that you have plenty of time to practice your own.
Me.
We have 20A plus 15C equals 340. And then A plus C equals 8. Jordan, help me out. What can I do here? I'm sorry, I thought you wanted to.
No, I
Okay.
did. I multiplied it by negative 20. Negative 20.
What variable is Jordan trying to eliminate if she's multiplying by negative 20? The A, absolutely. She would have written this out. The A's eliminate. What do I have if I combine my C's?
Negative 5.
And my constants?
60, right? Yeah. Negative 60. Or, yeah. That's what I think.
340 minus 100.
Oh, 100. What was it?
180.
And then you divide by negative 5. And that's how I solve C equals 12.
Wait, did I calculate?
I think yes. I think something was wrong because I remember getting like.
My goodness, what did I do wrong? Help me find it.
I can't see the board. I broke my glasses.
What did I do wrong?
Five
5 what?
5 divided by 180 is 12.
No, 12 times 5 is 60.
Yeah, so it was 160.
Yeah, but then I have to add them. The negatives?
Negative
340 minus 160.
Oh, I didn't get 340. I got 400. Negative 400.
But it was.
I got 20A plus 15.
Oh, I put 8 here. I'm so silly.
Yeah.
I'm so sorry.
So it's negative 400.
I was like, I know the answer to this. What happened? Negative 20 times 20 is negative 400.
Yeah.
Sorry.
Yeah.
I was jumping the gun because I knew there were 8 adults. Sorry. Okay, negative 5c equals negative 6c. Divide by negative 5c is 12.
Yeah.
Now the nice thing about the real world scenarios, for any of you who might have made a calculation error and you came up with a negative, not realistic because you can't have a negative number of tickets. If you did a calculation error and you came up with a decimal or a fraction, another one that could be a red flag here, right? We're not going to buy half of a ticket. Sometimes these real world scenarios allow you to find your own mistakes. For example, what I just did. I miscalculated because I wrote the equation wrong, and I all of a sudden was coming up with a different answer, even though we had already solved it over here with substitution, right? So sometimes going back and just catching a silly mistake makes a huge difference. Sorry for putting that up there wrong. My apologies. But I'm so glad you found my mistake. High level of thinking. Still being recorded, too.
No.
I say A.
Now, at the end of all of this, how can we check our work? When we just calculated C was 12, we were easily able to use this equation and say if children's tickets were 12, then adults would have to be 8, right? Which is true, but what else should we check just to make sure? We should still check to make sure that if I bought 8 adult tickets and I also bought 15 children's tickets, that I would in fact spend $340. Because imagine I made a calculation error like I just did, and I ended up with something like C equals 6. I can't just assume using this equation that if I had 6 children's tickets, there would be 14 adult tickets, right? Because my calculation error wouldn't have been caught. So you can try both equations here. How much would all of the adult tickets have cost if it was $20 for 8 tickets? $160 for adult tickets. And how much for the kids' tickets?
180.
Does 160 plus 180 equal 340?
Yes.
Yeah.
So we're good. It works in both. Woo. All right. Are you ready to try one completely on your own?
Not really.
You don't have to do it completely on your own. What we're going to do for this next one, we're going to peel the layer back a little bit. First one we did as a whole class. This next one, I want you to work with the people around you at your table. Try to isolate here, or not isolate, try to identify first your 2 unknowns. I'm going to read this problem for you, and then I'm going to slide over and pause the recording. Dan stocked up on batteries. He bought 8 packages of batteries. He bought 8 packages total, for a total of 62 batteries. If he opened up all 8 packages on a desk, there would have been 62 batteries there. The AA batteries are sold in packs of 6, and the AAA batteries are sold in packs of 8. We're going to write a system that can be solved to figure out how many packages of each type of battery Dan bought. Now, the one key I gave you down here, define your variables. Figure out what your unknowns are and what you're going to label them before you begin. And then work on writing both equations into a system. I'm going to pause the recording, and I'll add some time here.